Hybridization, okay, hybrid orbital is the new atomic orbital produced by hybridization process. This hybrid orbital is responsible for all sigma bond in the molecule. So hybrid orbital is actually new orbital. So in chapter 2.2, you learn about s orbital, p orbital, px, py, pz, d orbital. D orbital, there are 5 d orbital, xy, xz, yz, x squared minus y squared, z squared. Okay, so these atomic orbitals will mix together, okay, to form new orbital known as hybrid orbital. Okay, so basically there are 5 hybrid orbital which are sp. So sp is being formed when one s mixed with one of the p orbital. So you will get new hybrid orbital known as sp. sp2 hybrid orbital is a mixture of 1s with 2 p orbitals. Okay, sp3 1s orbital mixed with 3 p orbitals, px, py, pz plus with s. Okay, so sp3d, so 1s mixed with 3 p orbital and 1 of the d orbital. Same goes to this one. Okay, so next we are going to learn about hybridization process, how hybrid orbital is being formed. So in order to do hybridization process, you always need to draw Lewis structure. So based on correct Lewis structure, you need to determine number of electron group. So we look at the central atom. So basically there are 2 electron groups. So when you have 2 electron group, the type of hybridization that central atom will use is sp. If number of electron group is 2, so hybrid orbital sp. Number of electron group 3, so type of hybridization will be sp2. So kalau 2, ada 2 alfabet, ada 2 huruf sp. Kalau 3, dia ada 3 huruf lah, spp. Kalau 4, sppp. So that's why we call it as sp3. Okay, so after that, you need to determine correct molecular geometry. So in this case, is linear. And the most important part is identify sigma or pi and formal charge at central atom. Okay, so we look at central atom. So you need to identify how many sigma bond, how many pi bond, and formal charge only for central atom. So if we look here, central atom, you have 2 sigma bond. Okay, and then the formal charge for central atom is 0. Okay, so beryllium only has 2 valence electron. So the valence electron is at 2s. So if we look at the valence electron, how come this valence electron can make a bond with Cl? So beryllium need to have 1 electron here, okay, or like this, and then another electron here to share that electron to make a bond with Cl. So valence electron in beryllium is like this. So beryllium will use hybrid orbital. In other words, central atom will use hybrid orbital. Okay, so how to produce hybrid orbital? So one of the valence electron will be promoted, will be excited to 2p. So one s orbital mixed with one of the p orbital, so you will get new hybrid orbital known as sp hybrid orbital, like this. So when the electron is like this, so beryllium can make a bond with chlorine. Okay, so for chlorine, no need to use hybrid orbital. Okay, because chlorine has 7 valence electron, and then the electron that we'll use for sigma bond is this one. Okay, chlorine tak ada masalah. Okay, beryllium dia ada masalah sebab beryllium dia kena ada 2 orbital dan orbital tu dia mesti single electron, singly occupy. So, baru dia boleh buat sigma bond dengan klorin. Baru dia boleh buat sigma bond dengan klorin. So, sekarang ni valence elektron dia 2s. Dekat 2s ada 2 elektron. So, kita kena promote. Kena excite that elektron. Pergi masuk ke S. So, kita campurkan dua orbital ni. 2s dengan one of the 2p. So, kita akan dapat orbital yang baru. Okay? Okay. Macam mana shape orbital yang baru ni? Bila 1s bercampur dengan satu daripada p orbital, so dia akan dapat dua orbital yang baru yang dikenali sebagai sp. So bayangkan satu box ni merujuk kepada satu kelopak. So kalau ada dua box, dua kelopak. So bentuk dia adalah linear lah. Mengikut kepada shape yang kita tentukan dekat atas tadi. Okay, mengikut kepada shape yang kita tentukan dekat atas tadi. Okay, so this is how sp hybrid orbital look like. Okay, so Be will use hybrid orbital sp and chlorine will use 3p. Okay, so it will overlap and form sigma bond. So information ni tally lah dengan apa yang tadi kita investigate. Sebab tu part ni sangat penting. So masa awal tadi kita dah investigate beryllium ni dia ada 2 sigma bond dan formal charge dia kosong. Okay? Okay. Apa beza sp hybrid orbital dengan p orbital? Kena faham betul-betul. Sp hybrid orbital, setiap kelopak ni memberi maksud. Satu kelopak ni memberi maksud satu orbital, another kelopak memberi maksud another orbital. So sebab tu setiap kelopak kita kena label. Kalau p orbital, kita lukis satu dumbbell which is dua kelopak ni, kita consider sebagai satu P. So tu beza dia. sp dengan p orbital shape dia sama. Yang membezakan dia adalah kelopak dia tu. Kelopak dalam sp kita kena label dua-dua sebab dalam sp hybrid orbital dia ada dua orbital. Kalau p orbital, satu dumbbell ni, dia menggambarkan satu garis saja. Satu orbital sahaja. So, tu perbezaan dia lah. Sebab shape dia sama. Okay. So, this is how you explain overlapping in Be and Cl. Overlapping of bond between Be and Cl. Okay, next. So, first and foremost, when the question asks you to describe or explain, determine hybridization process in BF3. So, first you need to draw correct Lewis structure. Follow step by step. So, in this case, central atom is in complete octet. Okay, accession to octet rule. And then, we look at the Lewis structure. We determine number of electron group. So basically there are 3 electron group. So type of hybridization 3 electron group sp2. So ada 3 electron group. Alphabet dia pun ada 3 lah, spp. Okay, so benda paling penting sekali kita identify. So at boron we have 3 sigma bond. And then boron formal charge is 0. So basically boron need to have like this. In order to make a bond with fluorine. So, in order to make a bond, so we will use valence electron. So, boron basically has 3 valence electron. Okay, so we need to promote one of the electron. And then we will mix these 3 electron. We will mix this orbital to make sp2. So that's why boron are able to make 3 sigma bond to fluorine atom. Okay, so for fluorine, chlorine is in period 3. Fluorine is in period 2. Okay, so you should know that one. So for fluorine, in order to make a bond, fluorine will use 2p. Okay, how sp2 hybrid orbital look like? Similar to molecular geometry. sp2, the shape is trigonal planar. So every kelopak, okay, every petal, you need to label sp2. So this is the explanation.